Good day to you wherever you're watching from. My name is Dr. Nathaniel Milani, and in this video, I would love to explain the theory of multiple regression to you so as to give you understanding of the working of multiple regressions and the theory, the model, and the interpretation. Starting with what is multiple regression? Multiple regression examines relationship between one dependent variable and two or more independent variables. And basically, it is used for prediction. It determines the relative contribution of predictors. Over the years, um, I have always said it that for you to understand multiple regression, you have to understand correlations. In the case of correlation, we are actually looking at the relationship between one independent variable and one dependent variables. But for multiple regression, we are looking at the relationship between two or more independent variables and one dependent variable. So that's why we have a big R that speaks to relationship and it tells us about prediction, not actually causation, but prediction. Um, it also determines relative contributions. I always illustrate with when we have four people pushing a car. Let's say the car is the student score in mathematics, and the people pushing it includes uh, the parents' literacy level, availability of home lesson teacher, um, IQ of the learner, and finally, the school, sorry, the learner's resilience. Let's say that. So, we want to see the relationship of the four with that learning outcome. We want to see which of whether the four predicts and which of what's the contribution of them. So, when do we use multiple regression? When the predictors are more than one and when the dependent variable is continuous. The independent variable ought to also be continuous. Both variable must be on the continuous scale. I will report that when why is important because it's used in education, social sciences, economics, and health. Before we do multiple regression, it is good to actually run Pearson correlations to establish the relationship because the first thing we must actually establish is a relationship. That means each of those independent variables must be related, as it were, to the dependent measure. They must have a relationship with the dependent measure. If they are not related, it means we cannot actually go further to look into the extent to which they are jointly related. And the next thing we must confirm linearity of assumption and identify suitable variable. For instance, we may not actually have all the variables having the capacity to be in the linear model. I said it, we have four variable, the students, parent literacy level, having the home lesson teacher, students, maybe IQ, and maybe mental toughness and all of that. If we do correlation and they are not related, um, you can't proceed to do multiple regression because the point is that the assumption of multiple regression is that the variables that you are actually putting in the model they correlate properly, as it were. So it identifies, it detects multicollinearity Multicollinearity is a situation whereby um, the variables that's supposed to predict are related with one another, and that should not happen. For instance, when we do our multiple regression, it is expected that all the independent variables they don't have relationship with one another, because when we are measuring our relationship, we may be reporting the relationship between the variables that we are not interested in and we think is the real variable. For instance, all those four variables, which are the students having a home lesson teacher, the parent level of literacy, the IQ of the learner, and the student mental toughness. Those four variables, they are supposed to predict the achievement in mathematics. However, when all of them are now related with one another, that's when we have multicollinearity, which should not happen, which is widely discouraged when we are dealing with uh, multiple regression. And I said it, the last is that it justifies the use of regression. When something are not related, when those variables are not related, the independent, they are not meant to do multiple regression with them. That's why it is advised that you do correlations of many variables and you see those ones that are well related and you see those ones that are not also having multicollinearity in their model, then you select the one you are going to use. So correlation examines relationship, but regression explains prediction and contribution, as well as joint relationship. So look at this. Let's say Y is the achievement of the students, B naught is the coefficient, B1, sorry, B1, X1 stands for the first variable. Let's say let's say X1. Okay, let me see if I could just edit my slide a bit. So let's say S1 is equal to parents parents literacy level. S2 equals to students IQ. um X3 is equals to mental toughness, and let's say X4, if we go to X4, is home lesson teacher. Let's say these are the four variables. I want to take this to add, and so let's say this is now four. That means I have four variables. This is also four. I have four variables here, you know. So um let me go back. So I'm just trying to make a perfect illustration of the variables. So this is a multiple regression, parent literacy level, and all of that is there. So the point is that in the next slide, I'm going to make my Y something else. So let's start with that now. You can see in this slide, uh, this we said Y is academic performance. X1, it could be anything, could be any variables. You can see here, I put my own variable. Here also, it could be, if it was three, it could be, it's better between 4 and 6. I always encourage you not go ahead to do regression when you have 7 predictors but between 4 and 6x. So the marks that you should be considering is x6, as it were. You shouldn't do a regression of 12 variables against academic performance. And why is academic performance in mathematics? So the assumption of multiple regression is that there's linearity. I've already spoken about that. There is independence of errors. There is normality. There is homoscedasticity. That's talking about the variance, uh, the homogeneity of variance, and there is no multicollinearity. We must ensure that all these factors are actually uh, considered before we go into multiple regression. And when we want to run our multiple regression, three outputs. There are three outputs. We have the R and R square, we have the adjusted R, we have the ANOVA F test, we have the regression coefficients, and we have the p-value. Interpretation of R square is the proportion of variance explained by the predictors. If you remember, if there are four variables, those four variables, the multiple regression will give us the information on how they affect the variance of the dependent measure. How did they affect it? So the R square gives us the information on how many percentage of the changes in variance are accounted for by the independent measure. And we have the beta weights, which are talking about the contribution. The two things we must know is that positive beta weight, we have negative beta weight. The positive beta weight is talking about direct relationship, and negative beta weight is talking about inverse relationship. But when we are talking about beta weight, it is important to note that what we should consider most is that the uh, magnitude comes before the direction. I will explain that in the video where we are doing the analysis precisely. And it is good that they are significant. So we have the overall ANOVA table that tells us whether the model is fit. So the fitness of the model is actually determined by the ANOVA table. If the table is showing insignificant, it means the model that we have designed is not useful. We should go and do something else. And multicollinearity is talking about how correlation and check using VIF. The VIF value of 10, VIF value of less than 10 is accepted. So we will do all of that. We'll see the VIF values so that we will know whether we have correlations. The essence of this video is that you'll be able to understand when we start doing the SPSS or the video, the SPS version, so as you have understanding. So advantages of multiple, it handles multiple predictors and controls confounder and useful for prediction. The limitation is that it is sensitive to outliers. Then the assumption must be hit. That means um, the point is that the meeting of assumption is a very tall order. So you might not meet an assumption always. Then you talk about the correlation and causation of this stuff, right? So in conclusion, correlation prepares regression explains prediction, and improves research validity. In short, that's what you have to get clearly. Now, now we're going to look at some set of data to actually prove what we have actually discussed so far, um, as it were. The data we have is um, we have here, if you can see, the achievement scores of students, um, and there are 40 of them. The ID is just talking about the ID of those students. We have study habits of the students, we have motivational level, we have attendance percentage, we have parental education in years, we have years of experience. So in this multiple regression analysis, this data, the dependent variable which will stand for our y is actually um, the the achievement score of students, and the predictors that we are looking at are their study habits, motivational level, attendance, parental education, teachers' years of experience. We want to see whether all these five variables, as they were, as it actually predict the achievement score. And I said we should start from correlation. That's the first thing. We must determine whether the variables that we are considering are correlating with the dependent variable, the predictors. The dependent variable in multiple regression can also be called the criterion variable, as it were. So we will put all of them in this interaction to see, and we have already checked Pearson, and we say okay, just to see what we have here. And if you can look at it very well, you will see that this is the achievement score. The relationship of this place is also achievement score. Anything that they are the same, their relationship will be one. They will have a perfect relationship. But look at what we have. We have study habits. Study habit is having no significant relationship with achievement. It's having a negative relationship, but that relationship is not significant. That's what I meant to say. The study habit has a relationship, but the relationship is not significant. Motivational level has a positive relationship because the Pearson correlation value is 1.7, but the significant two tails is greater than 0.05. So this relationship is not significant. Look at it, attendance percentage is also having a positive relationship, but that relationship is not significant. Parental education is having a positive relationship with achievement score, but the relationship is equally insignificant. Also, teachers' experience has a negative relationship. You can see the value is minus 0.54, but the relationship is equally insignificant. So you can see clearly that the relationship that we have reported so far is not significant relationship. They are relationship that are not significant. You see, so because of this insignificant relationship, it is not right to proceed to carry out the multiple regression analysis for this variable, because all the for this study, because all the variables that we are considering, they seem to be insignificant, as it were, to the uh to the they don't have significant relationship. And I said what we must first check is that we must check for significant relationship before we proceed to running multiple regression, as it were. So I want to go ahead to show us another data set that will give us a better result. I deliberately did this so that we can understand that the correlation analysis that is carried out is actually um, having some importance. So look at this one. We have three independent variables, and we have the final exam score, which is the dependent. The criterion is final exam score, and the predictors that we are assuming are these three things, which are study hours, attendance, and prior test scores. So let's go ahead to do the correlation of this and see whether the variables that we have considered they are good enough in the model. I said it that we have to remove those ones that are not good. And looking critically at the result that we have, this is study hour, this is the final exam score with um study, this is final exam score, relationship between final exam score and study hour. Look at it. The study hour is 0.475, the R value that's positive and it is significant. So study hour should be in the model. It's eligible to be in the model. You know, we have another variable, attendance percentage is having a positive correlation 0.411 R small r, and it's also significant. So it should be there. We have prior test is 0.692, is having the highest R value and the significance is significant. So it should be there. Let's assume one of them is not significant. The next thing the researcher ought to do is to remove it from the model. The next thing that we are talking about when we are talking about multicollinearity is that those variables are not meant to also have relationship with one another. Look at this. Attendance and study hours, they are not related significantly. You can see attendance and prior tests are not significantly related. They shouldn't have so much of relationship, you know, as it were. Um, so let us continue. We now have a good data set now that we can run our regression. So we go to analysis, we go to linear, and we regress, start our regression um, there. So the criterion variable is the dependent, we put it, and the predictor variables are three. We also drop them in the place where they ought to be. Then we look at the statistics that we want to choose. It's already pre-selected. We already have what we needed. Let me look at options if there are things to. Uh, the SPSS does not give us the values through which we can measure the level of multicollinearity, as it were. But the point is that when we have our output of correlation, we could manually look at the level, but look at it in a very easy way. We have the collinearity diagnostics. So you could check that and see whether you have the collinearity diagnostics. The confidence level is already pre-selected as 95% confidence level, and we want to check the model fit. So we just say okay, and let's see what we have. So the first thing to check whether our model is fit is this ANOVA table. If you have an SPSS result output for multiple regression, the first thing you check is this ANOVA table. And if it is significant, it means your model is fit. The next thing to look at is this big R. You can see this big R is positive and the value is 0.943. What is speaking to is that all the three variables we have considered, they have a joint relationship that is strong, positive, very close to 1, because relationship should range from 0 to 1, and you can see 9.943 is close to 1. Now we talk about the adjusted R square. That's the R square value that we often use, and is 0.88. If you multiply 0.88 by 100, we have 88%. It means all the three variables that we have considered in this study, they account for 88% of the changes in variance that may be applicable to the dependent measure. That means the final score is responding to 88% of uh, the value. Now, look at this before we go on. Is this VIF is the collinearity value, for each of the dependent independent measure. And you can see that the VIF value is 1.03, 1.04, 1 point is less than 10. All the VIF value that we have is less than 10. So because they are less than 10, uh, they are all good for us to actually go ahead with them. So now I will do another video to explain this result properly. But for now, you can see study hours has a has a value that is uh 0.551. So study hour and is significant. You look at the beta value and significant. Attendance 0.442 is equally significant. Look at the beta and the significant. All the three are actually having a beta weight that is significant. And the prior test score is actually having the highest level of uh, the highest level of beta weight, you know. So what we can say now that this is a perfect model and it is accounting for 88% of the scores of learners in the dependent measure. That means their final score, the variance of the final score depends on the 88% of the total variance of the final score is accounted for by those three variables which we have considered. This same data will be used to explain multiple regression and interpretation of results perfectly in the next video. Thank you.